এটা আমার খুবই একটা ফেভারিট টপিক বিকজ ডু ইউ গাইজ নো হোয়াট ইজ pseudo force? Have you been familiar with the term pseudo force or League ball? So if you know, then this is the proper example of application of pseudo force. অলিক বল এখানে কাজ করে। সিউডো ফোর্সের প্রপার অ্যাপ্লিকেশন হচ্ছে এলিভেটরের মধ্যে একটা বডির মোশন। So while moving up in an elevator, sometimes we feel heavy a little bit, sometimes we feel a little bit light. So why it happens, how does it happen, I'll tell you everything in this video. And what is pseudo force, when does pseudo force work, how does it work, I'll tell you everything. So without any further delay, let's get started. So in order to know the motion of a body in an elevator, first you will have to know what is pseudo force. Pseudo force যেটাকে বাংলায় বলি আমরা অলিক বল, সেটা কি আমরা আগে জেনে নিই। Pseudo force is simply a normal kind of force, a Newtonian force you can say. Its equation is also F equals to ma. Fp is denoted for pseudo force. সো আগে আমরা দেখি যে সিউডো ফোর্সের তো আমরা বুঝতে পারলাম নর্মাল ফোর্স, নর্মাল নিউটনিয়ান ইকুয়েশন এটা ফলো করছে। তাহলে এটার হোয়াট ইজ দ্য ডিফারেন্স বিটুইন সিউডো ফোর্স অ্যান্ড নর্মাল ফোর্স? নর্মাল ফোর্সগুলো সাধারণত যে কোনো ফ্রেমে কাজ করে, বি এটা ইনার্শিয়াল ফ্রেম, বি এটা নন ইনার্শিয়াল ফ্রেম। হোয়াট ইজ ইনার্শিয়াল অ্যান্ড নন ইনার্শিয়াল ফ্রেম? দ্য ফ্রেম which is in rest or moves in a uniform velocity is called a inertial frame of reference, and the frame which is neither in rest nor moves in uniform velocity is called non-inertial frame of reference. অজড়িত নির্দেশতন্ত্র। তো নন ইনার্শিয়াল ফ্রেম অফ রেফারেন্সে সিউডো ফোর্সটা কাজ করবে। যে কোনো একটা ফ্রেম যদি সেটা রেস্টে না থাকে অথবা সেটা যদি ইউনিফর্ম ভেলোসিটি নিয়ে মুভ না করে, যার আসল অর্থ কি? যার আসল অর্থ হচ্ছে ইট শুড বি মুভিং উইথ অ্যান অ্যাক্সিলারেশন। একটা ডেফিনিট অ্যাক্সিলারেশন নিয়ে যখন একটা ফ্রেম মুভ করবে, দেন দ্যাট ফ্রেম উইল বি কল্ড অ্যাজ আ নন ইনার্শিয়াল ফ্রেম অফ রেফারেন্স। তো সেই নন ইনার্শিয়াল ফ্রেম অফ রেফারেন্সে আমরা সিউডো ফোর্স একটা কাজ করবে। তো সিউডো ফোর্সের এক্সাম্পল কি? একটা এক্সাম্পল দিলে আই থিঙ্ক ইট উইল বি ক্ল্যারিফাইড টু ইউ। আমরা যখন গাড়িতে চলি, সাপোজ আমরা একটু ইমাজিন করার চেষ্টা করি যে আমরা সিট বেল্ট লাগাইনি, সিট বেল্ট ছাড়া গাড়ির মধ্যে বসে আছি, অ্যান্ড দ্য কার ইজ স্পিডিং আপ রেকলেসলি, নট রেকলেসলি, স্পন্টেনিয়াসলি গাড়ি স্পিড বেড়ে চলেছে। তো কী হবে? আমরা কি স্থির হয়ে সিট বেল্ট ছাড়া সামান্য সিটটা একটু পিছনে টিল্টেড করা থাকে, তা আমরা কি সোজা বসে থাকতে পারবো? গাড়িটা চললে আমরা গাড়ির পিছনে সিটের মধ্যে এরকম পিছন দিকে লেগে যাই না? সো আ ফোর্স ইজ পুলিং বিহাইন্ড আস। গাড়িটা তো সামনের দিকে চলছে, তো গাড়িটার অ্যাক্সিলারেশন সামনের দিকে, আর একটা ফোর্স আমাদের পিছন দিকে টানছে। এই যে ফোর্সটা আমাদের পিছন দিকে টানছে সেটা হচ্ছে সিউডো ফোর্স, অলিক বল। আর এটা কোথায় কাজ করছে? গাড়িটার মধ্যে। গাড়িটা কোথায়? গাড়িটা কীভাবে চলছে? উইথ অ্যান ডেফিনিট অ্যাক্সিলারেশন। সো ইট ওয়ার্ক, সো দ্য কার বিকামস এ নন ইনার্শিয়াল frame of reference, and sitting into that car we also become a part of that frame of reference. That is why pseudo force works on us. আর আমরা তার জন্য আমরা পিছনে চেপে যাই আমরা। তার মানে সিউডো ফোর্স কীভাবে কাজ করে বোঝা যাচ্ছে না, নন ইনার্শিয়াল ফ্রেম অফ রেফারেন্স যেদিকে গতিশীল হবে তার অপোজিটে। Pseudo force will always be working opposite to the normal acceleration of frame of reference. Are you getting it? Pseudo force will always be working in opposite direction to the normal acceleration of a frame of reference. Okay? তাহলে তো সিউডো ফোর্স বোঝা গেল, সিউডো ফোর্স কোথায় কাজ করে সেটাও আমি এক্সাম্পল দিলাম। সিউডো ফোর্স তাহলে সিম্পলি এর ফর্মুলা আমরা এমএ ইউজ করব। তা এবার আমরা আসি যে মোশন অফ আ বডি ইন অ্যান এলিভেটর। বিভিন্ন কেস ডিফাইন করে আমরা কেসগুলো আগে দেখাবো। কেসগুলো ডিফাইন করার পর আমরা একটা নিউমেরিক্যাল দেখব, যার মাধ্যমে উইল বি ক্ল্যারিফাইড। সো স্টাডি কেয়ারফুলি। ফার্স্ট কেস, এই লিফট আছে, ঠিক আছে? সো দিস ইজ আ লিফট, এখানে একটা মানুষ দাঁড়িয়ে আছে। তাহলে এবার আমি বলছি যে ফার্স্ট কেসে লিফটটা অ্যাক্সিলারেশন নিয়ে উপরে উঠছে। দ্য লিফট ইজ মুভিং আপ উইথ অ্যান অ্যাক্সিলারেশন এ। তাহলে হোয়াট আর দ্য ফোর্সেস দ্যাট উইল বি ওয়ার্কিং অন দিস বডি? mg, that is its weight downwards. N, what is N? N is normal reaction exerted by the surface on the body. এবার this is where the turn comes. The lift is moving with an acceleration A upwards. So this becomes a non-inertial frame of reference because it gains a definite acceleration. So a pseudo force will be acting on this body in what direction? The direction opposite to the main acceleration of the frame of reference. So a pseudo force ma will be working on this body downwards because the lift is moving upwards. So we know that pseudo force works on a body opposite to the motion of the real frame of reference, right? So this becomes an inertial frame of reference. It moves up with an acceleration a, so a pseudo force will act opposite to it downwards, right? So n becomes sum of ma plus mg. N is upwards, that is the normal reaction, and the pseudo force and its own weights is opposite to it, so n becomes ma plus mg. M common name, we write it as n is equal to m into a plus g. So if there was no pseudo force acting on the body, simply n was balanced by mg, and now it is moving, and now the lift is moving up with an acceleration a. So after equating the pseudo force that is working on the body, the n becomes equal to m into a plus g, so it gains an extra term ma. So n becomes greater than mg because of this extra term ma. That is why going up in an elevator we feel a little bit heavy, because normal reaction exerted by the surface of the lift is normally greater than our own weight because of this extra term ma, right? So first case clarified. Now divide a sub case of the first case. This was suppose small a. Divide a second case. The lift is moving upward with retardation. Retardation means negative acceleration simply. So we will substitute this minus into this equation. Let's see what does it give. N equals to mg, a becomes minus a, so plus ma becomes minus ma. Taking common m, we write it as n is equal to m into g minus a. So in the first case we were provided an extra term ma, and in this case ma is being and in this case ma is being subtracted from the main equation, right? So in this case n becomes less than mg because of this subtraction of this extra term ma. That is why if a lift is moving upward with a retardation a, say, then we will feel a little bit light because normally n equals to mg, and in this case n becomes less than mg, right? So let's talk about the second case, when the lift is moving downwards. Suppose the lift is moving now downward with the acceleration a. In this case also normal reaction will work upward, and the normal weight of the body will be acting downward, mg. But in this case pseudo force will act in another direction, because in this case the lift is moving downwards, so the pseudo force will act opposite to its motion, so the pseudo force will act in this direction, that is Fp. Fp simply is equals to ma. So n becomes equals to n plus ma, n plus ma, the upward force becomes equals to a downward force, mg. That is why it gets balanced, n equals to mg minus ma. So in this case we see n is less than mg. So the body feels light. And if the lift, and what will happen if the lift is moving with a retardation in the downward direction, that is a becomes minus a. So we will substitute this minus into this equation. This gives n equals to mg minus of minus a, m equals to minus a, that gives us mg plus ma. So n becomes simply greater than mg, so we feel heavy. Okay, so this was the normal cases in regarding to motion of a body in an elevator. Let's see special to another cases. So we have seen while moving in downward direction, the normal reaction on a body in a lift becomes n equals to mg minus ma. The first case of the second case, in the last segment I have shown you that, right? So what will happen if this acceleration of this lift becomes equals to acceleration due to gravity? It may happen, right, that the elevator falls with acceleration due to gravity. Its acceleration becomes equals to g. What will happen? We will simply substitute this case into this equation, that gives us n equals to mg minus mg, because a is equal to g, that gives us 0. So the normal reaction on the body becomes 0. So what will happen? The body will simply float up, right? The normal reaction on the body is 0. So there will be no contact with the surface, because we know that normal reaction gets formed for contact. This is a contact force. So when n equals to 0, simply there is no normal reaction, so simply there is no contact, the body will float upward, right? So this is called the weightlessness case. Weightlessness case, right? And there is another case, that what will happen if this a becomes greater than g? Simply n equals to becomes mg minus ma, and we know a is greater than g, so it will give a, so if we take common minus, it will give m into a minus g, because a is greater than g, so there will be obviously a negative sign into it, right? So what does this minus negative sign means? This is called the case of super weightlessness, where the acceleration of the lift is greater than the acceleration due to gravity. And we know that if the weight working on a body is downwards, so the normal reaction will be upwards. And in this case, normal reaction will be upwards, right? Right? No, not right. I was just making you confused a little bit. Let's see again. In this case, normal reaction comes with a negative sign with it, right? So what does it actually mean? It means that the normal reaction is downwards. So you may be thinking that the normal reaction is downward, the weight is downward. Oh, why is it happening? How is it happening simultaneously, that the normal reaction and the weight is working on the same body in the same direction? So let me tell you, what you are thinking is completely incorrect, because in this case, negative sign means that the normal reaction is downwards. That is completely correct. but the weight now won't be working in downward direction, it will be working in upward direction. So everything that was in contact with the surface of the lift will get floated. It's like the first case, but in this case everything in the lift will lose its contact with the surface and will float upward. It's such like if this is the lift and this is the acceleration, then there is no normal force. So there is the normal force is equal to minus m into a dash. A dash is the effective acceleration. I'll write it a minus g as a dash. So the body, suppose it's a man going to his office and this is his suitcase, terrible suitcase, whatever, will float upward. This case is known as super weightlessness. The concept of Superman was derived from this. No, not actually, I was just joking. Okay guys, so now we have seen what happens actually when it comes to motion of a body in an elevator. Now we will implement our knowledge by doing a numerical. So we will get justified whether our knowledge, whether our implementation is right or not. So let's get started with a numerical based study, right? So after doing this numerical, I think your concept will be crystal clear. So in this numerical, we are told that in an elevator, a smooth surface with an inclination of 30 degrees is in rest, which is 2 upon root 3 meter long in base. The lift is moving upward with an acceleration 2 meter per second square. If a block is left to fall from its top position, when it will reach the bottom position, right? So this was a numerical asked in a school question, basically in 2016, I guess. So let me just do the numerical for you. So what we are told here, that in a lift, this is simply a lift, and this lift is moving upwards with an acceleration 2 meter per second square, right? This lift is moving upward with an acceleration 2 meter per second square, and this plane is inclined to 30 degree. If a block starts from here, so the time required by this block to come from the top position to the bottom position, I'll give it a name A, B, C. The time required to slide down, right? And this surface is frictionless surface. So we will now derive what is the G, what is the effective G, effective acceleration due to gravity working on this body. So simply a normal weight, that is normal G, works from the center of mass of this block, right? And as it is going upwards, a pseudo force will act on it in the opposite position, right? I have shown you in the first case. So the effective G will be G dash equals to G plus A. The lift is moving upwards with an acceleration A, so there will be a pseudo force, and for that pseudo force and extra acceleration, A will be working on the direction of G. So the effective acceleration that will be working on the body will be G dash equals to simply G plus A. A is 2 meter per second square, and G we will take G as 10 meter per second square. So effective G becomes 12 meter per second square, right? So we will have to derive the length of AV. So the length of AV can be derived as cos 30. We will take cos 30 is equal to AB by BC. We are given here that the BC is 2 by root 3. So simply AB becomes 2 by root 3 into 1 by cos 30. That is 2 by root 3 into 2 by root 3, 4 by 3 meter, right? And if actually G dash is working on the body, So the g dash will be working like this, and the component of this acceleration along the inclined plane will be g dash cos 30. Sorry, my mistake. The component of acceleration that will be working on this inclined plane will be simply g dash sin 30, right? This is this is g dash cos 30, and this is g dash sin 30. So we will take acceleration of this block as g dash sin 30. G dash is simply 12, sin 30 is half, that gives us 6 meter per second square, right? We know that if we think that length of AB is S, so S equals to half AT square, because initial velocity of this block is 0. S is AB, right? That is 4/3 meter. Half A means 6 and T square. The time required by the block, T is the time required by the block from coming A to B. That gives us T square equals to 4/9. That also gives us T is equal to 2/3. So the block will take 2/3 seconds to reach the bottom position, that is B, simply, right?